All right. So what we're going to talk about in these few videos here is a technique called trigonometric integration, right? And all this really means is just, we have a bunch of functions that are built out of trig functions, and we want to know how do we integrate them. So let's start with something simple here that hopefully you remember. There's a couple formulas that you're going to need to know. And my pen, if it would draw, is great. All right, so the ones we want to know are sine squared x is 1 minus cosine of 2x over 2. Right? That'll be quite important. Another trig identity that's quite important is the one for cosine squared, which is 1 plus cosine 2x over 2. Right? These will be somewhat important here. And of course, another one we'll use quite a bit is sort of the classic one that most people remember. Sine squared plus cosine squared equals 1. Right? So with these in mind, let's look at a few integrals. Right? So some of the basic ones here will be things like integral of sine to some power of x dx. So how do we attack something like this? Right, well, if n is 2, we've actually done a couple of these already in the problem sets. But if we have, say, sine squared x dx, to integrate that, we have to swap this for 1 minus cosine of 2x over 2 dx. And of course, then we factor out the 1/2, and it becomes a simple, straightforward integral. Right, so this becomes 1/2 x minus 1/4 sine of 2x plus c. Right, nothing too surprising here. Right, now when n is 3, something a bit different happens. There's no formula for the cube of a trig function, but that's okay, because it turns out if we have any odd power, it's going to work out really, really nicely. So if we have this, what we're going to do is split off one of those signs from the rest of them. So let me put the square in the first one here. Right? I'm going to split off that first one copy of sine from the rest. Right? Now notice here we have an even power, in particular sine squared. So what I can do is use the Pythagorean identity, this one right here, and I can swap this for 1 minus cosine squared x times sine of x dx. Now, what's the benefit in doing this? Well, the benefit in doing this is we can now make a u substitution. If we do the substitution, u equals cosine of x, then du is negative sine of x dx. And look what happens. We have that sine x there. We have that sine x there. This is why we split off one copy of sine. Right? So now that we have that, we can say, okay, well, this is going to be the integral of 1 minus u squared times minus du. And that's it. So this is now 1/3 u cubed minus u plus c. And so this integral is 1/3 cosine cubed x minus, minus cosine of x plus c. And there we go. So the odd power there was quite interesting, quite easy to integrate, sort of compared to this one. This one required a trig identity. I guess this one did too. But let's look at n to the fourth and really see if we can compare the difference here. So when n is 4, we have this here, okay, sine to the fourth x dx. So when we're trying to integrate this thing, it's a little bit different, right? Because the technique we used for sine cubed here, well, that worked out because we could split off the one extra copy and turn all the others into 1 minus cosine squared. But here, well, it doesn't quite work out so nice, right? Here, you know, there's no way to split off one extra copy. So what we're actually going to do is rewrite this as sine squared x squared dx, okay? And we're going to use the same trig identity we did for n equals 2. All right, so this will be 1 minus cosine 2x over 2 squared. All right, so now we're just going to sort of have to deal with that. All right, so we have to expand this out. One nice thing is I can pull out this 2, and it comes out front of the integral as 1/4. And here we have 1 minus 2 cosine 2x plus cosine squared 2x dx. All right. Now, with that integral, we can do this part, we can do this part, but we can't do this part. So we have to use that same trig identity again, well, the cosine version of it. So 1/4 parentheses 1 minus 2 cosine 2x plus, here I'm going to pre-split this up as 1/2 plus 1/2. Now, since there's a 2x in here, we're going to get a 4x out here. All right? Hopefully this makes sense here. So now we just need to integrate these pieces. So this is 1/4. I'm going to combine the 1 and the 1/2 here, these two things together. So that's 3/2. So this gives me 3/2 x. Integrate this, and I have minus cosine of 2x, or minus sine of 2x. Right, and then here, integrate this, I have plus 1/8 sine of 4x. And all of that plus c. Right? So this is how we integrate the fourth power. All right? So these powers, now the same kind of process applies for cosine as well. If we had just cosine squared, we use this identity. If we had cosine cubed, we split off one copy of cosine. This is 1 minus sine squared instead when we apply the trig identity. Here, you're going to follow the exact same procedure. Right? You're going to rewrite cosine to the fourth as cosine squared squared. Right? And so on. And the nice thing is, these two right here kind of form the prototype of how you take care of any higher power, right? So here, with n equals 3, let's say we had n equals 5. I won't actually compute the integral all the way, but let's say n is odd, right? So that means n is something like 2m plus 1. Right, m is some integer here. Okay, if that's the case, then sine to the nth power of x dx, well, we're looking at here integral of sine of 2m to the x times sine of x dx. All right. Now this 2m power here, we just want to rewrite it as sine squared x to the mth power times sine of x dx. So sine squared is 1 minus cosine squared. Right? And we do the exact same u substitution. U is cosine x. Du is negative sine of x dx, right? So after the substitution, this integral is going to turn into the integral of negative 1 minus u squared to the mth power du. All right? So at this point, you have to, depending on what your m is, you'll have to expand this out and compute the rest of it. But that's sort of the prototype of how this one works out. All right? And the even one, right? So you're going to follow the same logic here. This 2 will become, whatever number it has to become. So like if n is 6, this will be a 3. If n is 8, this will become a 4, and so on, right? And so what you'll have is you have to, expand this out. You'll get this cosine squared again, except this time you'll have something like cosine of the 4th, let's say. And you just have to keep re-expanding any higher powers of cosine. Right, so I'll leave it at that for this video here. Hopefully this gets you a good start on these. And yeah, see you in the next one.